Calculation of the oxidation number of elements in a compound. Calculation of the oxidation number of elements in a compound. You know, this is very essential and very important, okay, as a chemistry student, because sometimes when you are naming a compound, okay, you need to first of all know the oxidation number of the metal, most especially transition metal, okay, or some special elements that have variable oxidation states when they are combining in a compound. So it's very important for you to know how to calculate the oxidation number of these elements. For instance, most times in a compound, they ask you how to calculate the oxidation number of, okay, to know the oxidation number of some element like sulfur, okay, or like phosphorus, or the transition elements like copper, like zinc, like iron. Okay, so that is why it is very, very important for you to know how to do what? Calculate for your oxidation number. Very, very important. So let's go. I'm going to be showing you how to do this using the following examples. It's very, very important. Calculate the oxidation number of the underlying elements in the compound and also name the compound. Okay, I have told you that there are old ways of naming compound, but generally now we have what we call IU part nomenclature. That is, I stands for international, U stands for union, then of P, that's applied of pure and applied chemistry. That's international union of pure and applied chemistry. So there is a standard for naming compounds. Okay, so let's go now. So you calculate the oxidation number of the underlying elements in the compound and also name the compound. See the first one here, there's the second one, the third one. Look at this now, they look alike. But you see that this one do not have a subscript, okay? But this has a subscript. That you see now that there are two copper here, but here there are what? Just one copper, one oxygen. Here there are two coppers, then one oxygen. Here we have one ion, then two chlorine. So we solve for this. But before we do the solution, there are rules you need to first of all know when you want to calculate for your oxidation number. The oxidation number. The first one is that the oxidation number of a compound, okay, that is, sorry for the writing, the oxidation number of elements, okay, in a compound, the summation, that's the total oxidation number of elements in the compound, is always equal to 0. Okay, when you add the oxidation number of the different elements together in a compound, you are to get 0. Okay. Now, number 2, the oxidation number of oxygen, okay, in a compound, in a general case, is always equal to what? -2. Okay. Then oxidation number of hydrogen also in the compound, in most cases, apart from hydrogen peroxide, is always what? +1. The oxidation number of elements in its uncombined state, when it has not taken part in a chemical reaction, it is always equal to what? 0. Okay, so sodium atom has what? 0 oxidation state. Chlorine atom has what? Or chlorine gas has what? 0 oxidation state. Okay, then the last one, oxidation number of monoatomic ion is equal to its ionic charge. What do we mean? When you have sodium ion, okay, remember it's what? It is Na plus. Okay, Na plus. This is called sodium ion. Then this is called sodium atom. neutral atom. Okay, so there's a difference. So for this now, the oxidation number is not equal to 0 because it has a charge. But for this, the oxidation number of this is not equal to 0. So with this knowledge now, let's solve our questions. Alright, solution. Number 1. Quickly. So from the known we derive the unknown. So let's represent, oxidation number of copper as this be equal to X because it is unknown. Now, oxidation number of oxygen, that is, remember it's always what? Minus 2 in a compound. So therefore, remember also the total summation of elements, the oxidation number of elements in the compound is always equal to 0. So let's put this together. That of copper is equal to X plus you add it up, right? Then for oxygen, remember it's a minus 2. The reason why we put this bracket so that we can have a correct answer equal to what? 0. So X plus times minus give you what? Minus 2 equal to 0. Are you following now? Good. Now X. You know, this is 0, right? This is minus 2. And this is X. This is a letter and this is a number. So there's no way you can add a number and a letter together. So what do? You take it to where numbers are equal to. So when a negative number crosses the equal to sign to the other side, it becomes what? Positive. So it becomes 0 plus 2. Do you get it now? Good. So X therefore equal to plus 2. Always add a plus so that we'll be sure what we are talking about. If you don't have a plus, all you are saying is what we are calculating. We are only telling us the valency. Okay? But with the sign tells us that what it is oxidation number. Good. So the second part of the question is, let us name it. So when you want to name, okay, when you are naming, sorry, I'm going to click this. Okay, let's do it. Let's come here into this. Okay. 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 Let me name here too. Alright, let's do the naming. This is okay, we are naming this. So if you want to name it, you name them one after the other. This is copper, this is oxygen. Okay, but don't forget, in naming compounds like this, you need to what? Add the oxidation state. Since they have variable oxidation state, we want to know what is the state of copper in this compound. So how do you name? Just say copper, the first element, sorry, copper, without spell copper. Then you open a parenthesis. Then you write the oxidation number using the Roman numeral format. That's, remember, it's I for 2, okay? Then copper 2 is not going to be oxygen again. It becomes oxide. So when oxygen is combining, it's in a compound. It's not called oxygen, but it's called what? Oxide. Oxide. Good. So let's do for the second one. Right, that's this. Remember, this and this are not the same. We have just one copper here, one oxygen. But here we have 2 copper, we have 1 oxygen. So the oxidation state of copper here will not be the same thing with the oxidation state of copper here. So what do we do again? Let the oxidation number of be equal to X again. Are you following now? I hope you can see the board. Okay, good. So remember that oxidation number of oxygen equal to what? Minus 2. So let's put them together. It becomes X. Is that so? No. How many copper do we have? You have copper to go 2. So it is not going to be what? It is not going to be X. What do? It is 2. Sorry. It is 2 times X. Okay? Let's do it like this. Then plus. What's the oxidation number of oxygen? Minus 2 equal to 0. So 2 times X will give you what? 2X plus times minus will give you what? Minus 2 equal to 0. Good. Please let me do this. So let's further continue. So it becomes what? This is an algebra, okay? Algebraic expression. This is 2x and this is minus, this is 2. So there's no way you can combine them together. So what you need to do is that you will take the number to where numbers are. So 0 is a number, so you take it to the other side of the equal sign. So it becomes 2. I'm sorry, please. 2x equal to, this goes to the other side, becomes 0 plus 2. I hope you're following good. So this is 2x equal to 0 plus 3 equals plus 2. Always do it as plus 2. Okay, so now, is this all? No. What you do is that this is 2x, this is 2. Okay? If we divide both sides by 2, we'll be able to eliminate the 2, getting the coefficient of x. That's taken out. So divide by 2. Divide by 2. Alright? This is 2 cancel 2. Remaining x equal to 2 cancel 2. Remaining 1 plus 1. So therefore, the oxidation state of copper in this compound is what? Plus 1. So how do we name it? Since we have got the oxidation state, the same thing you do. Write copper first, copper. Copper. What's the oxidation state of copper in this compound? It is what? 1. Then oxygen as well. You understand? Yes. So I believe with this now you understand how to solve for your oxidation number, okay, of elements in the compound and also how to name them. So please do well to solve for number 3. That's FeCl2. Let me see your answer in the comment section. Okay, let me see your answer in the comment section. So please do well to like the video, give me your comments, then what? Do well to subscribe, please subscribe.